Good evening, scholars. I hope all is well with you. This is Mr. Lowe, and I am recording this video lesson for the start of section 8.1, which is the beginning of unit number 8 on rational functions. In this lesson, we will look at what a rational function is, finding elements called excluded values, and then looking at how to simplify a rational expression. So this video will be uploaded to Google Classroom for you to view and to complete the assignment that goes with it. So today we will explore rational functions and expressions. So start our exploration of them. Now, of course, there's solving equations of rational expressions. There's adding, subtracting, multiplying, dividing rational expressions, graphing rational functions, so on and so forth. But there are a few concepts that we need first in order to do that. I need to make one thing clear, though, before we start this unit. Everything in this unit involves fractions. That's what the definition of rational is, something that can be written as a fraction. So therefore, do understand that we are going to be working with fractions. So if you have a fraction phobia or if you struggled with fractions in the past, that's okay. There's no judgment in that. But do know that you're going to have to put in the work with fractions in order to be successful in this unit. With that being said, let's begin. A rational function is a function where the expression is a quotient of polynomials. In other words, it is a function made up of a fraction. That's simple. So notice that you have 4 examples here, different types. Sometimes you have a number sitting at the top of a fraction. Sometimes you have an expression sitting at the top of a fraction. The most important part is the bottom. For a rational function, you're going to have variables sitting at the bottom of a fraction. Now, why is that important? That brings up one of the most common rules that you've been told since you've been studying mathematics, and that is you cannot divide by 0. That rule still holds true. You cannot divide by 0. So since you cannot divide by 0, we have to find what numbers will cause the bottom of the fraction, the denominator, to be 0. That has a specific name to it, that name being an excluded value. An excluded value is any x value that makes the function undefined. So remember, undefined means having a 0 at the bottom of a fraction. You cannot divide by 0, so 0 cannot be there. So to find excluded values is pretty simple. Set the denominator equal to 0, and then solve the equation. Do keep in mind, factoring might be involved. You could have factoring in the problem. So let's go ahead and begin with some very basic examples. Y equals 10 over x. So the denominator is x. Take the denominator, set it equal to 0, and then solve it out. So in this case, x equals 0. So your excluded value is x equals 0. Your excluded value is x equals 0. That means you cannot plug 0 into that function because it will make the denominator 0. Example 2, same thing. Take your denominator and set it equal to 0. So 9 minus 3x equals 0. So you're solving a standard equation. Subtract 9. Negative 3x equals negative 9. Divide by negative 3. X equals 3. So your excluded value is x equals 3. So if you need proof of why that's the case, it's very simple. If you plug in 3, 3 times 3 is 9, and 9 minus 9 is 0. You cannot divide by 0, so that means 3 can't get plugged in. 3 cannot be plugged into the problem. Couple more examples. Example 3, 4x equals, f of x equals 4x over 5x minus 6. So, one thing to make perfectly clear, the numerator does not matter. Numerator does not matter. It is the denominator that matters. It is the denominator that matters. So you take the denominator and you set it equal to 0. So 5x minus 6 equals 0. Add 6 to both sides. So 5x equals 6. Divide both sides by 5. X equals 6 over 5. So your excluded value is x equals 6 over 5. 6 over 5, 1.2 means the same thing. Means the exact same thing. Exact same principle. Last but not least, example 4. Y equals 2x minus 1 over x squared minus 3x minus 10. So again, the numerator, which is the top of the fraction, can do whatever it wants. So you do not have to worry about the top of the fraction. It is the bottom of the fraction that you are concerned with. So x squared minus 3x minus 10. Now, the fact that you see x squared in there should be telling you that you need to factor. Should be telling you that you need to factor. So all of your factoring rules still come into play. So you have 3 terms. So that's an MAF problem. So there's no number in front, so this is basic MAF. 2 numbers that multiply to 10, negative 10, and add to negative 3. That's negative 5 and positive 2. Negative 5 and positive 2. There's no number in front, so x minus 5, x plus 2 equals 0. So you take each factor and set it equal to 0. So x equals 5, x equals negative 2. So that means your excluded values are x equals 5 and x equals negative 2. You cannot plug those 2 numbers into the problem. You'll get a 0 in the denominator if you do. So as far as excluded values go, that's that. Set the denominator equal to 0, and then solve it. Solve that equation out. Note that sometimes you're going to have to factor it. So that's excluded values. The other thing that we will touch upon in this particular section is dealing with how to simplify a rational function. How to simplify a rational function, which we'll do now. So, simplifying a rational function is essentially reducing a fraction. Simplifying a rational function is reducing a fraction. It's just like reducing a fraction. So that means you need to take the biggest thing you can out of the top and bottom of the fraction. Out of the top and the bottom of the fraction. So if you look at examples 1, 2, and 3, these are the baby examples that you've been doing since elementary school. Baby examples that you've been doing since elementary school. So 12 over 24, you can divide the top and the bottom by 12. Divide the top and the bottom by 12. Gives you 1/2. Gives you what? 1/2. Example 2, 18 and 50. You can divide them both by 2, which is 9 over 25. You look at 9, you look at 25. There's nothing else that can come out. So that's your final answer. And we'll look at one more of just numbers. 120 divided by 12. You can divide the top and the bottom by 12. 120 divided by 12 is 10. 12 divided by 12 is 1. So you have 10 over 1. But anything divided by 1 is itself. That gives you 10. So that gives you 10. So first three examples are the numbers that you've been working with. The numbers that you've been working with all along. So as we scroll on over to variables, the concept is still the same. We need to divide the top and the bottom by something that they share. Now, when variables come into play, it does get a little bit hairier and a little bit more complicated sometimes. i.e., you better be prepared to probably factor for some of these problems. So let's take a look at example number 4. So example 4, you have 3x to the third, 3t to the third divided by 12t. 3t to the third divided by 12t. So if you look at just the numbers, so you have 3 over 12, so you can divide both of them by 3. So that gives you 1t to the third divided by 4t. But now you have to pay attention to the variables too. T to the third and t. You can divide those out as well. So remember, if it's the same variable, then you can subtract the exponents. So that's t to the third, and this is t to the first. 3 minus 1 is 2. So that's 1t to the second divided by 4. Or you could just write it as t squared divided by 4. So again, you're simplifying the expression. So example 5, of course, factoring can come into it. Now, here's one thing that you cannot do. Someone's going to look at the 24 and the 20 and ask yourself, oh, well, I can divide by 4. I can divide those by 4. No, you can't. That 24 is connected to the 6, and that 20 is connected to the 5. So you cannot divide them out that way. So in the case of 5, 6, and 7, and 8 and 9 after it, we are going to be factoring. We're going to be doing quite a bit of factoring. You have to know how to factor in order to simplify an expression. So here's when it starts to get difficult. So you got to know your factoring rules. So example 5. So 6x minus 24. Well, you're probably thinking to yourself, oh, well, both of them divide by 6. Good. That means you can reduce. You can factor it out. So that's a GCF problem. 6 parentheses x minus 4. If you factor the denominator, ooh, that's GCF as well. 5 over 5 parentheses x minus 4. So look at what the top and the bottom share. The top and the bottom share x minus 4. So since they share it, what do you get to do? You get to cancel them out. You get to cancel them out because they share it. So your answer is 6 over 5. Your answer is 6 over 5. So watch what took place there. Factor the top, factor the bottom, and then cancel out what they share. Factor the top, factor the bottom, cancel out what was shared. So get used to hearing that a lot. Example 6. 3x squared minus 9x over x minus 3. So same rules apply. Factor the top. Remember, the first rule of all factoring is GCF. So we can take out a greatest common factor. You can take out a 3, and you can take out an x. So that gives you x minus 3. The bottom is just x minus 3. You can't take anything out from that. Can't take anything out from that. So notice what is shared. X minus 3, x minus 3. So those will drop out. So that's 3x over 1. So if the denominator completely drops out, then there's a 1 sitting down there, which you can simply write as 3x. You can simply write it as 3x. So again, as it starts to get more complicated, those factoring rules are going to come into play. Factoring rules are going to come into play. So example 7. K plus 1 over k squared minus 4k minus 5. So if you look at the numerator, k plus 1, you can't really do anything with it. So that stays. K squared minus 4k minus 5, we can factor this. That can be factored. So first rule of all factoring is GCF. Can't do anything with that. Second step then is to do MAF because there's 3 terms. So your M is -5. A value is -4. So we need 2 numbers that multiply to -5 and add to -4. The only 2 numbers that would work are -5 and +1. -5 and +1. There was no number in front of k squared, so we can easily write it as k plus 1 and k minus 5. So look again. K plus 1 at the top, k plus 1 at the bottom. So those are your shared terms. So they drop out. So at the bottom of the fraction, you're left with k minus 5. At the top of the fraction, k plus 1 drops out. So that means you're left with 1. Again, if the denominator clears out, you put a 1 down there. If the numerator clears out, you put a 1 up there. If something clears, you put the 1. Something clears out, you put a 1 up there. So 1 over k minus 5 is your final answer for number 7. Your final answer for number 7. So let's continue on. So example 8, y squared minus 16 over y squared minus 8y plus 16. Now, again, here's a warning for you. You cannot just say, oh, I have 16 and 16. I can cancel those out. You can't do that. You cannot do that. You cannot do that. The top 16 is connected to y squared. The bottom 16 is connected to 8y, which is connected to y squared. You cannot do that. So don't get into a habit of doing something that does not work. It does not work. You need to factor. You got to factor. So y squared minus 16 is difference of two squares. So y plus 4, y minus 4. The denominator is an MAF problem. So two numbers that multiply to positive 16 and add to negative 8. That's negative 4 and negative 4. So you have a shared term. So you have y minus 4 at the top. Now you have two y minus 4s at the bottom, but you can only cancel out one of them. You can only cancel out one of them. You can cancel out 1 for 1. That's it. Don't get greedy. 1 for 1. That's it. So those drop out. You have y plus 4 over y minus 4. So again, please don't get greedy. You cannot cancel out those two y's because they're connected to something else. You cannot cancel out the two 4s because they're connected to something else. Don't get greedy. Don't get greedy. So last but not least, example 9. C squared plus 9c plus 18 over 2c squared plus 3c minus 9. So once again, if we try to factor it, the top, you have 3 terms. So this is an MAF problem. So multiplies to 18 and adds to 9. Multiplies to 18, add to 9, so that's 6 and 3. So you have C plus 3 and C plus 6. So pretty straightforward. The denominator is also MAF, but you've got a number in front now. So this is one of those MAF plus grouping problems. So let's first start with the MAF. So M, first and last term, 2 times negative 9, that's negative 18. The A value is 3. So that gives you 6 and negative 3 as your two numbers. So it's an MAF plus grouping problem. So now you're going to take 6 and 3 and separate the problem. 2c squared plus 6c minus 3c minus 9. Remember, when you change it to a grouping problem, you take your two factors and you separate the middle term. Take the two factors and you separate the middle term. Now with grouping, first group you can take out 2c, which gives you c plus 3. The second group you can take out negative 3, and that's c plus 3. So remember, you did grouping correctly if the parentheses matched. So what you see twice, you write once, and the two parts that were left over, you put them together. So that's C plus 3 and 2C minus 3. So once again, notice that the C plus 3's match. C plus 3's matched. They drop out. So you're left with C plus 6 over 2C minus 3. That is your final factored answer. That's the final factored answer. So one thing with simplifying rational expressions, there is a heavy dosage of factoring, knowing how to factor. Again, the first three examples, basic numbers. The fourth example, still working with numbers and basic variables. But past that, GCF, MAF, difference of two squares, MAF with grouping, you need to know how to factor in order to be successful in this unit. There's really no way around it in this particular unit. So if you need the extra help, you got to ask. You got to put forth the effort to do it correctly. Otherwise, this unit's going to be a struggle. So with that, that completes section 8.1. Again, this video will be up for you as you practice, as you continue to really just plug away at making sure to do this concept correctly. If you have questions, feel free to ask. But with that being said, I'll sign off of here for now. You take care and have a good one.